So we will be dealing with Fourier series and Fourier coefficients. Here's the formula for the Fourier series. F of x is equal to a sub 0 over 2 plus is a summation of a sub n cos n pi x over L plus b sub n sine n pi x over L. And we have the Fourier coefficients. Each coefficient has their own purpose and value. So we have a sub 0 is equal to 1 over L integral of f of x dx. A sub n is equal to 1 over L and the integral of f of x cos n pi x over L dx. And b sub n is equal to 1 over L integral of f of x sine n pi x over L dx. So we have to remember that a sub n deals with the even part of the equation or the f of x, while this b sub n deals with the odd part of the f of x. Okay. So here are some of our few of our examples. So first we have we will solve for the Fourier series of x squared in the over the integral of negative pi and pi. Okay, so first we have to solve for the, let's start with the a sub 0. So for the a sub 0, we have the formula 1 over L integral of f of x dx. So this is the easiest part of solving Fourier coefficients in series. So we have to analyze the given. So we have x squared. X squared is an even number. So if this is an even number, we have to change this with 2 over pi, and the integral should be from 0 to pi. And let's just copy this one, x squared, and write dx. So now all we have to do is to find the integral of x squared. So if we integrate this number, we'll just have to add 1, and the exponent of our given will be the denominator. So here we will have x cubed over 3, since 2 plus 1 over 3. And what happens to this integral sign? This integral sign will be placed after the number that we have integrated, and we'll just write evaluated from pi to 0. And now all we have to do is solve. We'll just have to substitute this pi from x and 0 to x, and let's just subtract the 2. So we'll have pi cube over 3 minus 0 cube over 3. So this will equate to 0, and we'll just have to multiply this. So we will have 2 pi cube over 3 pi. If we will simplify this, we will have 2 pi squared over 3. So this will be our a sub 0. So now we will solve for a sub n. A sub 1, we have the formula 1 over L times the integral of f of x cos n pi x over L dx. Okay? So since we have an even since the f of x is even, we will just repeat the following. We will place, instead of 1 over L, we will place 2 over pi. Integral from 0 to pi. F of x is x squared. Copy. Cos nx dx. So since we have this type of equation, we won't be needing this L since we don't really have a period. We will be using the integration of parts. So I'm sorry. The integration of parts has the formula u times v minus the integral of v du. In this case, ru will be x squared. I'll just write it. Let's just do it here. Ru is x squared, and the derivative, we will get the derivative of our u, which is du, and our du will be 2x dx. So the difference between the integration and derivation is that in the integration we will add the exponent. We will add 1 to the exponent, and the exponent will be a denominator. While in derivation, our exponent, we will subtract 1 to our exponent, and the n will be moved at the before the variable, and it will be 2x. Okay, so our dv is cos nx, and we will find the derivative of this one, which is 1 over n sine nx. So how did this become 1 over n sine nx? Cos nx, we will just have to get the term before the x, which is n, and we will just have to write it here before the trigo function. We'll just write 1 over n. We just have to divide this by 1, and then change this cos to sine, the sine function, because sine is the cos is the derivation of sine, and sine is the derivation of cos. Okay, now we will follow this formula, u times v. So we will put it here. Ru is x squared times v, 1 over n sine nx, minus the integral of v du. V du, our v is 1 over n sine nx, and du is 2x dx. And now we'll just have to solve. So here we will get x squared sine nx over n minus. So now we will have to multiply this one to this one. So we will have the integration of 2x over n sine nx dx and we can just draw this out of the equation, this 2 over n, 2 over pi x squared sine nx over n minus 2 over n integral of x sine nx dx. So as you can see, we can still do an integration, another integration of parts. We have the value of u here and our value of dv here. Okay, so now we will just write this x squared sine nx over n minus 2 over n. Our u is x, our du is simply dx or 1 dx. I'll just write it as dx. Our dv is sine nx, and our v will be negative 1 over n cos nx, because the derivative of sine is negative cosine, and derivative of cos is positive sine. Don't forget the negative sign when you're derivating from sine to cos. Okay, so now let's follow the formula. So we will have here, we will have u times v, which is x times negative 1 over n cos nx minus the integral of v du, negative 1 over n cos nx times v du dx. Let's write this here, x squared sine nx over n minus, so we will just have to distribute the x sign to this, we just have to multiply these two terms. So we will have negative x cos sine nx over n, and here we will have, let's just pull out the negative sign, so this will become plus the integral of 1 over n. We can just pull this out, we can just move it here. Yeah, we can just move it here, so we can just say plus 1 over n cos nx dx. Over n minus x cos nx over n minus 1 over n. So now if we will integrate this one, we will have sine, we will have 1 over n sine nx. Okay. So now we will just have to distribute this one to in multiply terms. We just have to simplify the terms. So we will have x squared sine nx over n minus plus uh, 2x cos nx over n squared plus I'm sorry, I forgot. This term is included in this term. So we will have to distribute 2 inside terms. Okay, so yeah, we have this term here. And now we will have minus this will be 1 over n squared. So we will have 2 over 2 sine nx over n cubed. Okay, and we are left with this term. So all we have to do is to evaluate this from pi to 0. Okay, so now let's just substitute the value of x to pi and subtract it to the substituted value of x, which is 0. So 2 over pi x squared. So x squared will be pi squared sine n pi over n plus 2 pi cos n pi over n squared minus 2 sine n pi over n cubed minus 0 squared sine n 0 over n plus 2 times 0 cos n 0 over n squared minus 2 sine n 0 over n cubed. So sine n0 or sine n pi will always equate to 0. So we will remove this term. This will equate to 0. And this will equate to 0 since cos sine of 0 is equal to 1. But if we multiply it by 0, it will be 0. And this will be 0. And now we can either do this by 2 ways. We can get the GCF, or we can just assume that this will cancel out. So we can just cancel this out. So 2 over pi times 2 pi cos n pi over n squared. Okay, so now we are left with 4 pi cos n pi over n squared pi. So we can cancel this out. So we will have 4 cos n pi over n squared as our a sub n. There is no need to solve for b sub n since our b sub n will equate to 0. Why is it equated to 0? Because if our f of x is an even number, then b sub n will automatically be equal to 0, since there is no odd number to solve for. And now let's just arrange this in the form of the Fourier series. So we will have our Fourier series for this one is, let's write this down. Fourier series, we will have x squared is equal to, our a sub 0 is 2 pi squared over 3, and our a sub n is 4, so we will have plus, we can just write this down as infinity and it's equal to 1. A sub n is 4 cos n pi over n squared. 4 cos n pi over n squared. And that will be our Fourier series. You can just add cos nx. This is our Fourier series for the number 1 question. Okay. So now we will deal with the second problem. The second problem is, it requires us to find the Fourier coefficients of f of x is equal to 5 x 0 x 5 period 10. Okay, so first we will look for the a sub 0. A sub 0 is equal to 2 over p from, first we have negative 5 to 0, 0 dx plus 2 over p from negative 5 to 0, 0 to 5, sorry, from 0 to 5, 3x dx, 3 dx. Okay, so now we'll solve for the integral of 0. The integral of 0 is just simply 0, so cancel out, and now we're left with this one. So our period is given 10, so it will be 2 over 10 integral of 0 to 5, 0 to 5, yes, we just put it here, 5, and then 3 dx. And now what is the integral of 3? It will be, wait, 2 divided by 10 is simply 1 over 5. And the integral of 3 is 3x. 3x evaluated from 5 to 0. So we have 1 over 5, 3 times 5 minus 1 over 5, 3 times 0. So we have 15. 15 over 5, this will be 0. So we have 3 as our a sub 0. So now we will solve for a sub n. A sub n deals with the cosine value. So we have, as we all know, we have 1 over 5. Okay, 1 over 5 integral of negative 5 to 0, 0 cos n pi x over, our L is simply 5. So instead of placing L over here, we will just use 5 because 2 divided by 10, 2L is equal to 10. So if we divide it by 2, we have L is equal to 5. Therefore, 5 dx plus 1 over 5 integral of 0 to 5 3 cos n pi x over 5 dx. So now we will solve for the integral. So this will be automatically be considered 0 because if we multiply 0 to cos, it will just turn into a 0. So we are left with 1 over 5 with this term. So now in order to solve this, we will have to pull out the 3. So we will have 3 over 5 integral of 0 to 5, and then we will get the derivative of this one. So we will have 5 over n pi cos n pi x over 5 dx. Yes, and we will pull this out. So we have 15 over 5 n pi integral of cos n pi x over 5 dx. And now we simplify. 15 divided by 5 is 3 over n pi. And the integral of this one, it will be simply sine n pi x over 5 divided from 5 to 0. And we'll just substitute the value of 5 to x and 0 to x and subtract them both. So 3 over n pi sine n pi 5 over 5 minus 3 over n pi times sine n pi 0 over 5. So sine n pi 0 is automatically considered as 0. So we're left with this one. So we have this will cancel out. So sine n pi is also considered as 0. So therefore, we are left with 3 over n pi, which is then equal to 0. So our a sub n is equal to 0. And now we will solve for b sub n. B sub n is equal to b sub n is equal to 1 over 5 integral of negative 5 to 0, 0 sine n pi x over 5 dx plus 1 over 5 integral of 0 to 5, 3 sine n pi x over 5 dx should be equal to, this will automatically be considered as 0. Pull out the 3, so we have 3 over 5. Integral of 0 to 5, 5 over n pi sine n pi x over 5 dx, multiply outside, so 15 over 5 n pi 0 to 5, or we can just simply put negative cosine negative cos n pi x over 5 related from 5 to 0, so this will be 3 over n pi times negative cos n pi x over 5 to 0. Now substitute the x part, 3 over n pi times negative cos n pi 5 over 5 minus 3 over n pi minus cos n pi 0 over 5 . And then we will just distribute, so we will have, okay, sorry for the interruption. So here we have these terms, so as you can see we can just cancel out the 5's, and 0 divided by 5 is just simply 0, but cos 0 is always equal to 1. Okay, so in order to let's just combine the terms. So we have 3 over n pi 1 minus cos n pi. So this will be our final value for Bn. So these are the Fourier coefficients of this given. In a sub 0 we have 3, a sub n we have 0, and in b sub n we have 3 over n pi times 1 minus cos n pi. Okay, so for today, we will solve for the Fourier series of, our third problem is in search of the Fourier series of one plus sine squared x. Of course, our standard interval is from negative pi to pi. So first we'll solve for a sub 0. So for a sub 0, we have 2 over 2 pi, since this is standard, and from negative pi to pi, 1 plus sine squared x dx. So we will split this in two. So we have, simplify this one, 1 over pi from negative pi to pi 1 dx plus 1 over pi from negative pi to pi sine squared x dx. Now we'll take the integral of this one. So this integral of this one is 1 over pi x evaluated from pi to negative pi plus the integral of sine squared x is 1 minus the trigonometric equivalent of sine squared x is pi to pi is 1 minus cos 2x over 2. 1 minus cos 2x over 2 dx. But we'll have to separate this term here. So we will have plus 1 over pi times 1 over 2 integral of negative pi to pi 1 minus cos 2x dx. Now we'll just have to multiply this one. So we'll have 1 over 2 pi and the integral of 1 is simply x, and the integral of cos 2x is sine 2x over 2. So here we will have x minus sine 2x over 2 pi to negative pi. So we have the value of the first and the second term. Now all we have to do is to do the operations. So here we have 1 over pi times pi minus negative pi plus 1 over 2 pi times pi minus sine squared pi over 2 minus negative pi minus sine squared negative pi over 2. So here we'll have this will be positive pi, pi plus pi is equal to 2 pi. So 2 pi times 1 over pi equal to 2 pi over pi plus, so here we'll just have sine 2 pi will just equate to 0. This will equate to 0. If we transpose this sign to this sign, it will be plus. So all we have left is 1 over 2 pi times 2 pi. And here we finally we have 1. Here we have 2 plus 1. So therefore our a sub 0 is equal to 3. Now we'll solve for a sub n. Our a sub n, it deals with the even function of the f of x. So here we have so since we have an even function, we this is our given 2 over period from, so since we're dealing with the an even function, the limit of the integral will change from 0 to pi. Okay, from 0 to pi. 1 plus sine squared x cos nx dx. So this is our given, and then since we're dealing with even, we won't have a 2 pi on our period, so instead we will just have a pi. So 2 over pi, split the two values, so 1 cos nx dx plus 2 over pi times the integral of from 0 to pi from sine squared x cos nx dx. So now we'll just have to simplify the two terms. So 2 over pi, the integral of 1 cos nx dx is simply sine nx over n. Simply sine nx over n, evaluated from pi to 0, plus 2 over pi, value from 0 to pi. The value, the trigonometric value of sine squared x is simply 1 minus cos 2x over 2, and let's just copy this cos nx dx. This will cancel out. So in this first term, if you'll imagine, we'll have sine n pi, it will equate to 0, sine n 0, it will just equate to 0. So this, we'll just have to disregard the first term as 0 because it's not really important. So we'll just bring this down here, and just put it down here, so we'll have enough space. So we'll have 1 over pi integral from 0 to pi. So we'll remain with 1 minus cos 2x times cos nx dx. So now all we have to do is to multiply the inside terms. So we'll have 1 over pi 0 to pi cos nx dx minus 1 over pi from 0 to pi cos 2x cos nx dx. So there's another trick for solving these values. So we can use 2cc method. The formula of a 2cc method is this one. 2cc is equal to c plus c, where 2 cos m theta cos n theta is equal to cos of m plus n minus cos plus cos of m minus n, and we just have theta both sides. So this is the formula of the 2cc method, also known as a cc substitution method. Okay, so now we'll just have to implement this method to our second term here. So 1 over pi from 0 to pi cos nx dx minus, now we'll have to multiply the 2 to our second term. So 1 over 2 pi limit from 2 cos 2x cos nx dx. So now all we have to do is to substitute the terms. We'll just imitate this term here, and now we'll have let's just rewrite the terms. Cos nx dx minus 1 over 2 pi. So now we'll just have 0 to pi. We'll have cos 2 plus n x plus cos 2 minus n x dx. And now we can just integrate this one. So this integration of this one will simply be 1 over pi times sine nx over n evaluated from pi to 0 minus 1 over 2 pi So here, if we integrate this one, we'll just have cos, we'll have sine, we'll have sine 2 plus nx over 2 plus n. We'll just use, this is just over 1. To integrate this, we have a 1 value at the bottom. So we'll have to divide this value by 1. We have to divide 1 by this value in order to get the integral of this, and just simply change cos to sine. So we have this one. And then plus sine 2 minus n x over 2 minus n evaluated from pi to 0. Okay, so here we have sine nx, sine n pi and sine 0 pi will just equate to 0, so this is just 0. So we're left with negative 1 over 2 pi times so here we have sine 2 plus n. Yeah, we have sine 2 plus n over 2 plus n times pi plus sine 2 minus n over 2 minus n pi minus, we have sine 2 plus n 0 plus sine 2 minus n over 2 minus n 0. So here we'll just have a 0 value, because if we multiply 0 to this one, we'll just get a sine 0, so that will be 0, and this will get 0 as well. This will be 0 as well. If we multiply sine 2 pi or sine n pi, we'll just get 0, which is 0. So we are left with negative 1 over 2 pi times 0, so it will just be a 0. So therefore our a sub n is equal to 0. But it's not true for n sub 1 and n sub 2. So we'll at least have to input a value of n in order to have a value of, so we can have a value of for a sub n. Okay, just get another paper. So now let's just repeat the process, but this time we'll use a sub 1. Okay. So our a sub 1 is equal to or we'll just copy the term here. We'll just shortcut our way through. Let's keep the part over this one, 1 over pi. Okay. So now we have 1 over pi from 0 to pi, 1 plus sine squared x cos nx dx. Okay. So here we have one over pi from 0 to pi cos nx dx plus 1 over pi from 1 minus cos 2x cos nx dx. Shortcut. And then now we have, I'll just rewrite this one over here, 0 to pi cos nx dx plus 1 over pi actually this will just equate to 0, so we can just disregard this term. So here we have from 0 to pi, here we have, here we have cos nx dx minus 1 over pi cos 0 to pi cos 2x cos nx dx. So now we'll just use the CC 2cc method. So here we have 2cc is equal to c plus c, where 2 cos n theta and cos n theta is equal to cos m plus n plus cos m minus n. And we just have to substitute this value. So our first term will remain as is. Okay. So we'll remain with 1 over pi 0 to pi cos x dx minus 1 over 2 pi 0 to pi. So we have 2 cos 2x cos nx dx. So we can just have cos x dx minus. So for our value of n, we will put 1. Okay, so we will just place 1. So this time we have 2 over pi 0 to pi cos of 2 plus the value of n 1 x plus cos of 2 minus 1x dx. And we can just look at the integral of this one. It will be just 1 over pi sine nx over n from pi to 0. This will just equate to 0 as usual. So this will be just be 0. And then here we will have negative 1 over 2 pi integral from 0 to pi cos 3x plus cos of x dx. So now we just get the integral of this one. So 1 over 2 pi from 0 to pi multiplied times sine 3x over 3 plus sine of x from pi to 0. Okay. So now we have to substitute the value for this one. So negative 1 over 2 pi sine 3 pi over 3 plus sine 3 minus sine 3 0 over 3 plus sine 0 So here again we'll just get a 0 value in our inside value. So multiplied negative 1 over 2 pi times 0 will just be 0 again. So a sub 1 will be equated to 0. Okay, let's repeat it again. This time we'll get a sub 2. Let's try a sub 2. A sub 2 is equal to 1 over, let's take the shortcut, 1 over pi from 0 to pi 1 plus sine squared x cos nx dx. And so here the first value will be disregarded since it is 0. So let's jump with the second term. So 1 over pi integral from 0 to pi sine squared x cos nx dx. Okay, so here we have 1 over pi from 0 to pi. Sine squared x will just be equated to 1 minus cos 2x times cos nx dx. Multiply the inside term, so we have 1 over pi from 0 to pi cos nx dx plus minus, I'm sorry, we have minus 1 over pi from 0 to pi. We'll just have 2 cos 2x's cos 2x cos 2x dx. So now let's just implement the 2cc method. So for our 2cc method, we have 2cc is equal to c plus c, 2 cos n theta cos n theta is equal to cos m plus n plus cos m minus n. So this is our 2cc formula. We'll just implement this in our second term. So here we have 1 over pi times, let's just simplify this one, sine nx over n, from pi to 0, 1 over 2 pi, from 0 to pi, we have 2 cos values, so cos 2 plus 2, value of n, x plus cos 2 minus 2x dx. This will just be equated to 0, so we'll just focus on this second value. So here we will have negative 1 over 2 pi. So this will just be cos 4x. The integral of cos 4x will just be cos 4x over 4, sine 4x over 4. So we have sine 4x over 4. Okay, this will just be cos 0x. The integral of cos 0 is 1. Cos 0 is always equal to 1. So here we will have just the value of, and the integral of 1 is just x. So we'll just add plus x of pi to 0. And then substitute the values. So we have negative 1 over 2 pi sine 4 pi over 4 plus pi minus sine 4 0 over 4 plus 0. So we will be left with sine 4 0 is 0, here's my 0, sine 4 pi. So we will just be left, it will be 0, so we are left with pi. So pi times negative 1 over 2 pi is negative pi over 2 pi. Simplify. So we have negative 1 half as our a sub 0, a sub 2. Okay. So our Fourier series for, we forget b sub n. B sub n will just be equated to 0 since our f of x is an even function and there is no odd part of the function. Okay, so to complete this one, we have the Fourier series of, okay, so 1 plus sine squared x. Okay, let's just assume that t is an x, so we're a bit confused. So we have a sub 0, 3 over 2 plus our a sub n our a sub n, which is negative 1 over 2. So we have minus 1 over 2. Minus 1 over 2 from infinity n is equal to 1. Our inner value is cos nx. So this is our Fourier series. So for our fourth problem, we have to look for the interval and radius for summation of 0, 1 over negative 3, 2 plus n squared plus 1, and 4x minus 12 raised to n. So here we have to look for the interval and radius of convergence for this given. Okay, so just have to simplify this one. So this will be written as four x minus 12 raised to n all over negative 3, 2 plus n, and n squared plus 1. So here we have to look for the absolute value. We have to split this term. We have to get the reciprocal of this one, and this term, numerator and denominator. And then for every n variable that we can see, we'll just have to add 1 plus 1. So here, so this will be 4x minus 12 raised to n, so that will be raised to n plus 1 over negative 3, 2 plus n plus 1, and then we have n plus 1 squared plus 1 times the reciprocal of this value. So we just have to copy this one. So we have 4x minus 12 raised to n over negative 3 raised to 2 plus n over n squared plus 1. I'm sorry, we have to forget. We get the reciprocal of this value. So for our numerator, we'll have negative 3 raised to 2 plus n squared plus 1 over 4x minus 12 raised to n. Okay, so now we have to deal with these terms. So now we'll have to cross multiply. So 4x minus 12 raised to n plus 1 over times 4x minus 12 raised to n. That will just leave us with 4x minus 12. And then negative 3 raised to 2 plus n times negative 3 raised to 2 plus n plus 1. So this is simply n plus 3. This will simply be n plus 3. So this will be simply n plus 3. So here we will be left with negative 3, negative 3. Yes, we'll be left with negative 3 since we will just have to subtract this 3 and 2 times n squared plus 1 over n plus 1 squared plus 1. So here we'll just have to simplify this value. We have to expand that one. So in order to expand that, we have n plus 1 times n plus 1 inner outer terms, n squared plus n plus n plus 1. So we have n squared plus 2n plus 1. So since we have n squared plus 2n plus 1, we have another plus 1. So this will just become n squared plus 2n plus 2. Okay, so now we'll just have to copy this term. N squared plus 1 over this value, n squared plus 2n plus 2. And now we have to isolate the term with the x variable from the n term. Now we'll be left with, this will simply just be 1 over 3 absolute value of 4x minus 12 limit as n approaches 0, n squared plus 1 over n squared plus 2n plus 2. So if we will substitute the infinite value to n, it will just be equal to 1. So infinity squared and infinity squared plus 2 times infinity, this will all just equate to 1. So we have 1 over 3 times 4x minus 12 times 1. So now we're looking for the interval of this term. So in order to look for the interval of this term, we have to isolate the x variable. This will be our middle term, and it should be less than a negative number and less than a positive number. So in order to do this, we have to do this one. Wait. Okay. So here, let's just assume we have 1 less than 4x minus 12 over 3 less than 1. So 3 will just have to multiply 3 here and to this value here. So we'll have negative 3, 4x minus 12, and 3. So since we're left with this value, now we will just have to add 12 on both sides. So the absolute value of 12 is positive 12. 12 minus 3 is equal to 9, negative 9. Negative 9. (12 plus 3 is equal to 15. So we're left with 4x. Just divide both sides, all terms by 4. So we have negative 9 over 4, so less than x, less than 15 over 4. And this here is the interval of our term here. This is the interval. So in order to check for the radius, we have we just have to subtract 15 over 4 and 9 over 4 all over 2. So to put it here, we have 15 over 4 minus the negative 9 over 4 all over 2. So if we will be left with 15 over 4 plus 9 over 4 over 2. So if we add both these terms, 15, 5, 6, 7, 9, we're left with 24 over 4 over 2. We'll be left with 6 over 2. So therefore, 3 will be our radius. This will be our radius. So to put it simply, we have, for our given, we have the interval. We have the interval of negative 9 over 4 and 15 over 4, and the radius of 3. So this will be our final answer. Okay, so we have the last number, which is to find the interval. Find interval and radius of the summation of from n is equal to 0 to infinity. We have 4 raised to 1 plus 2n over 5 raised to n plus 1 times x plus 3 raised to n. Okay, so we'll just have to add n plus 1 to the n terms. So 4 raised to 1 plus 2 times n plus 1 over 5 raised to n plus 1 plus 1, and we have x plus 3 raised to n plus 1 multiplied by the reciprocate of this one. So we have 5 raised to n plus 1 all over 4 raised to 1 plus 2n times x plus 3 raised to n. Okay, so simplify. So we will have 4 2n plus 2. So here we will have 1 plus 2n plus 2, so 2n plus 3, x plus 3 raised to n plus 1 over 5 raised to n plus 2 times 5 raised to n plus 1 over 4 raised to 1 plus 2n times x plus 3 raised to n. Okay, cross multiply. So here we will be left with 4 squared times x plus 3, 5 raised to n plus 1 over 5 raised to n plus 2. We will be left with just 5. And now we will solve for the interval of convergence. So we will be left with 16 over 5, and we'll have to enclose this term, the x term, with the absolute value, x plus 3. So we all know that x must be less than 1, and this must be less than negative 1. So we'll reciprocate 16 over 5 and multiply them on both sides. So we will have negative 5 over 16 less than the absolute value of x plus 3 and 5 over 16. So now all you have to do is to distribute the negative signs, the 3 term on both sides. So now we will have negative 5 over 16, negative 3. So we will have, the least common denominator is 6. So we will have 16. Sorry, 16 divided by 16 is 1 times 5, negative 5, and here we will be left with 16 times 3 is just 16 times 3, 6 of 18 plus 1, 48, so we will be left with negative 48. So we are left with negative 53 over 16. Okay, negative 53 over 16 less than x. So here we same thing, but the difference is the sign. So instead of negative 5 over 16, we will have 5 minus 48 over 16. So this will just equate to 43, negative 43 over 16. So negative 43 over 16. So here is our interval. And now we will solve for the radius. So for the radius, we have radius. So for radius, we have negative 43 over 16 minus 53 over 16 and over 2. So we have 53 all over 16 minus 43 over 2. So we will be left with 10 over 16 over 2. So this will simply be equated to 5 over 16 simplified. So this will be our radius. So therefore, our interval for this question is negative 53 over 16 and negative 43 over 16, and our radius is simply 5 over 16. So here is our final answer.